Hey Chem 30, this video is our acids and bases introduction, which will eventually lead us into equilibrium that involves acids and our bases. So all chemical reactions are either a transfer of the hydrogen or a transfer of electron. So this is looking more at a transfer of the proton with this, and so we've seen water as H2O, but we're going to think of it as HOH for this outcome. Okay, and so we've got our water. What really ends up happening is we end up with a hydroxide ion, so an OH1 negative, and then we have our H1 plus. So our acids are things that are sour. They're electrolytes. They turn blue litmus paper red. They're going to give off a hydrogen ion. They're going to react with the base, and it loses its properties. So when those two come together, they end up neutralizing each other, and our pH is going to be 6.99 and anything lower than that. And so I would suggest writing down your notes so that you have them to look back on. So bases are bitter. They again are electrolytes. They turn red litmus paper blue. They're going to give off hydroxide ions. They're going to react with an acid and loses its properties. And then it's going to be anything that has a pH of 7.01 and higher. So the next video is really going to look at pH and pOH and all that kind of stuff. Okay, so we see acids and bases all over. We see them in lemon juice. We've got them in vinegar. Anything there. We've got a base, could be baking soda, an oven cleaner, a Drano. There's lots and lots of different places that we're going to see acids and bases. So this would be a sort that we would normally do. And so we've got 3 different types of acids and bases that we can have. And so we've got, which we've looked at before, but you're going to have your binary acids, you're going to have and then your 2 different types of oxy acids. Okay, so a binary acid is going to be named hydroblankic acid. Okay, so this is going to be, so know your binary acids. We've got hydroblankic acid. This would be hydrobromic acid. Okay, so this is a quick review. If you need to go back and look at the acids video from Physical Science 20, they'll be on the Physical Science 20 website. That is always available to you. Okay, so again, we're taking the root word of our bromo and putting it into hydrobromic acid. Okay, so our oxy acids, if we have an 8, so again, it's coming from your pink sheet. It's going to be, if you've got a nitrate ion or a sulfate ion, this would become nitric acid. You're getting rid of I'm pointing at the screen, you're getting rid of this 8, and it's becoming ic, so that it can become nitric acid. So same thing down here, if you've got sulfate, it's going to become sulfuric acid. I'm going to write this part down. Okay, so our other types of oxy acids, we have an ite, and so ites can become us. And so for sulfite, if you have a sulfite ion in that, it's going to become sulfus acid. So sulfus acid sounds kind of weird, and so this one's actually going to be sulfurous acid. Okay, so an Arrhenius acid, you need to write this down. It's a compound that dissociates and forms an H1 plus, or essentially it's a proton. Okay, so for this, if we've got one hydrochloric acid, it's going to end up breaking down into a chlorine and a hydrogen. Okay, they end up separating into a chlorine and a hydrogen. And so when they're separated, we end up with a 1 plus, oh my goodness, a 1 plus charge on our hydrogen, and then our chlorine would end up with a 1 negative charge. Okay, so what also can happen is you get our water, the hydrogen's going to come over and join that other oxygen, and then the chlorine's going to end up by itself. And so we'll end up writing this out. So I would write this down on in your notes as well. And so here, if we're writing a dissociation equation, we've got a hydrogen ion that's coming from that. So we get a hydrogen ion. Why is that light too weird? We get our hydrogen ion and our bromide ion. So the other way that this can look is we've got our hydrogen that's going to come over here. So we could end up with an H3O 1+. This is going to be aqueous, plus our bromide is going to be by itself. So both of these are options of how you can write it down. So here, that hydrogen ion, what's end up happening with that, with those H3, when we end up getting that H3O like 1+ or a hydronium ion, is that hydrogen has come and it's joined over. Okay, so for this one, when it dissociates, we only want to lose one of those hydrogens. So I'm going to have H1+, and then I'm going to go plus. I've got HSO4 because I've only lost one of them. 1 negative. This one's going to be an aqueous 2. And so every time that we do it, we only can lose one hydrogen. So same thing down here. I've got end up with H3O 1+ plus that HSO4 1 negative. So an Arrhenius base is going to be a compound that dissociates and produces a hydroxide ion. Okay, so pay attention to this because your Arrhenius bases are different than your Bronzite Lowry, which is the next one, or the next type that we're going to learn. So again, Arrhenius can only have that OH, 1 negative, that's produced. Okay, so if we're looking at the dissociation of this, we've got our sodium hydroxide. This would end up dissociating into a sodium ion and our hydroxide ion. Okay, so another example of this, if we've got magnesium hydroxide, this can dissociate into magnesium ion, and then we're going to end up with 2 hydroxide ions that are completely dissociated apart. So this is a little bit different than the acids that we had seen. So anytime that we've got a base, we can completely dissociate that. Okay, so write this down. Know that an H1+ is going to be equal to a hydronium ion, which is that H3O 1+, and all of those really are saying that it's a proton.